A demonstration of the Arbin Instruments BT2043 battery test system. It is a computer-controlled battery test piece of equipment designed for research and development and for the production of batteries and any energy storage device. The system is powered by 208 volts 3-phase, requiring a 42 amp service. It has a range of from 10 volts, from -1 to +100 volts, and a current range of up to 25 amps. First, we'll take a look at the back. There isn't much here. These are the cooling fans. They should always be kept clear. This is the main power connection down here as well. It is also important to note that this is a 3-phase system, and if any of the phases are not in the correct phase, the system will not start. You may have to reverse 2 of the phases. However, there is a small sight glass right here, and what this sight glass will tell you is if you look in there, you'll see a green light. As long as that light is illuminated, the phases are in the correct order. For purposes of our demonstration, we have hooked up some devices on channels 1 through 6. I have 1 ohm 25 watt resistors. On channel 7 I have a 0.1 ohm or 100 milliwatt 400 watt resistor. A 100 milliohm resistor, 400 watts. And on channel 8 I have 2 golf cart 6-volt batteries connected in series, which gives me 12 volts for our battery test. Now, turn the system on. One button. When first coming on, these are 2 power supplies. They should be illuminated with both a green and a red light. These are your main test channels, 1 through 8. Normally the bank of channels on the right side are illuminated with a green LED. Also, the system not only has the 8 main test channels, but let me explain these channels up here. These are all your auxiliary channels. You have 16 temperature channels where you can hook up a T thermocouple and measure temperature. You have 40 auxiliary voltage channels. These strictly are for measurement. They measure your device, they tell you how much voltage is throwing through that. We have additional leads down here that come with the instrument, but for purposes of our demonstration, I have hooked up 8 auxiliary voltage channels, and through the software I've hooked them up and linked them to the 8 main channels as well. If your application requires you to measure pressure, you can obtain the correct pressure transducer and hook that up here to the 8 pressure channels as well. Now we will start the system computer. While we're waiting for it to boot up, all communication is done through this one cable here. That's a standard communication cable that goes to the back. We have this set up so you don't need a password, just hit enter and you'll get to the main screen. Now, to start the Arbin software, there is a little icon up here called console. You would double click on that, and that brings up your first screen. Now, before we even continue, there is a manual that goes with the piece of equipment. And everything that you see on the screens here is represented in full color in the manual. In addition to that, this entire manual is in the software as well. If you go to the help right here, open that up, you'll see that there's a complete description of how to run the software. For example, if you had to create and edit these steps, it would take you through page by page what you would see in the book. So you can always minimize this and keep it off to the side if you have to refer to it, and that's very helpful. From the main screen here, we're going to go through each of the main routine steps. Schedule files. Schedule files are your actual programs. This is where you would enter the values that you want to test, whether that be a range of current, a range of voltage or power. Next are the batch files. The batch files are what actually runs your program files or your schedule files. It allows you to assign your program to different channels and make different measurements. There's your results file here, which is all your results. Basically, they are stored and can be reproduced in Excel very easily, which we will show you in a few minutes. And then there's system configuration. That tells you exactly what's in the main Arbin box as well. As you can see, we have 8 main channels, 40 auxiliary voltage channels, 16 temperature channels, and 8 pressure channels as well. Now, to actually launch your measurement software, there's a little space shuttle icon here that you would click on. And what that also does is it starts this window here. Now, this is your communication port. When you see that this is tracking along, instant created, you have communications with the Arbin system. If you should stop running the test, it would stop as well. So if you have a problem, just remember you have to launch before you do anything else. We'll put this away. Now, the way that this is presented is there are 8 main channels here, but as we mentioned, there are a number of auxiliary channels as well. So to link those to the 8 main channels, I'll minimize this and I'll go into our batch file. I'll open our systems file. Now here are our 8 main channels. I call it linking, they call it mapping. So we would go into map, and as you can see here, I've put in auxiliary voltage, temperature, and pressure for each of the main channels, and then taken their channels and assigned them to them accordingly. Now once we have that in place, we can save that. We'll relaunch, and as you can see, it's now displaying our auxiliary channels. Normally when this particular screen first comes up, it is somewhat compressed. So it's always helpful to expand it. Just so you have a pretty clear view. Now, there are 4 different types of displays. There is the detailed displays, which shows you all 8 channels at once. There's also a brief view. The brief view will just show you the actual status of the channel running, whether it's idle, whether it's finished, and when it's running, it'll display the actual current and voltage running. Also, if you should ask the system to do something that is over one of the customer preset limits, it will also show you unsafe. It'll shut the channel down. So there's a lot of safeguards involved in making sure that you don't push the limit when it comes to this piece of equipment. I can tell you, you have to be very careful with it. You can overheat. That's why I have temperature probes on here. You can overheat your devices, and incorrect use, some people have been known to actually destroy their device. However, as long as you follow the instructions and you know what you're working with, it's very important to know what you're working with. You can easily set up the safety limit margins so you won't have any problems in that area. There's a graph view that allows you to, in real time, graph your test as well, whether it be current versus time, date versus time, voltage versus time, and then there's an individual channel view. So depending, for example, this is on channel 1. See, they do the same thing here too. When it first starts up, they compress all this down. I like to be able to see it. So this is sort of nice, and you can actually run your test from the screen as well, and the same color coordinated status bar will come right up in here. So now we're going to go back and we're going to run our first test. I have devised 4 different tests just to give the system a good run through. I've made a test for current, one for power, expressed in watts per hour, one as a voltage ramp, and one for internal resistance. Now, first we're going to run the current test. Again, the setting up of all of this programming can be found in the manual or on the PC inside the software, or Arbin themselves has a very good set of video tutoring software that you can run through as well, that will take you step by step through all these screens and will show you all the different ways of setting up your scheduling files and everything else that goes along with setting up the system. It will take you some time to get through this, but between this and the on-screen electronic manual, with a little practice, you shouldn't have too many problems. So now let's start by, we'll run our first test. We're going to run current, and first let's take a look at it. Now, we're going to run this test, just brush on a few things here. We're going to start this test by resting. We're going to get everything set, and then after it times out for 10 seconds, we're going to run a current test where we're going to want to maintain the device at 1 amp of current. And we're going to do that for 30 seconds. We've set up our limits so that we will run from -1 to +1 amp, and in a voltage range of -2 to +6. Now, there's a couple of different ways to start your test, but either way you have to select a channel. It's simple to do. Just go on the channel and do 1 left click, and you select the channel. Now, there's 2 ways to actually start. The easiest way is to use the running man icon. Go up to the top here, you'll see the running man, and if you push that, it'll say start channels. You must give it a name. Now, I've made a name for our demo test. We call it test 1. You hit OK, and this simply says it'll overwrite any pre-existing data, and there you go. You start your test. Now the first thing that's going to happen is it's going to rest, and then it's going to charge. When it charges, it will be displayed in blue. Take a quick look at our brief here. As you can see, it's running right now. And it is clocking down. And the step time is, I believe, 30. And it says it's finished. We can look at that channel by going right here. And we can see that we maintain right at 1 amp. The other thing that can be done here is if, let's say we go back to our main screen, we can launch Excel, and we just ran that one test, and if we go to Arbin data, we can import those results. Here is our first channel, our test 1. And we're just going to import the data in standard spreadsheet form. Or, we'll close that. Or we can import the data and plot it at the same time. And here we have our plot. We wanted to maintain 1 amp of current, and this is our voltage in milliamps. Save our nice little screen here, and we'll close our Excel. Now we can go back to our close this down for now. So we've run that first test. Now what I'm going to do is I'm going to run a current test on all the channels at one time. That one we just did. We're going to do it again, and this is the other way you can start the channels as well. Again, you left click on the channel, and then you right click on the channel, and it'll say start channel. It'll do the same thing as the running man at the top of the screen in the running man icon. Test 1, and here we go. Take our brief look here, see it's still running. It's finished. And I think we're all done. Go back and take a look. Yes. Now what I did here is I ran our current tests on these first ones. And then I ran a voltage ramp and an internal resistance on these last two. Now, again, you can put all of this into Excel and you can plot it out or present your data in spreadsheet form. All right, now that we've run our tests on our 8 main channels, One of the things that you can do is you can also test the hardware independently here. Simple. We'll go back to our main screen, and next to our little space shuttle we have this icon here. If you click into it, that's the calibration window. This will also give you a very simple diagnostics test for testing all of the 8 main channels. Right now, our put a desired value of 0 here. 0 simply means that it will not produce any voltage, any current. It's just open circuit. It's just to see if the channel's on the air or not. We're going to start with channel 1. We're going to only count 1 channel, and when we push set, channel 1 will go on. As you can see, channel 1 went on, and when you hit next, you've tested that. You can also test all 8 of them at one time if you wish. You hit that and all 8 will go on. Notice it's showing that there's no current being run through. This is just simply a, if you want to call it, a static test. And we can turn it off. Again, you can move these around just to give you an explanation of what everything is before we finish up here. This is your test name. You can create your own tests. These are your programs, or as they refer to them, schedules. These are where you decide on what, whether you want to test for current or voltage or whatever. This is the status of it, where it will show you whether it's charging, discharging, finished, or unsafe. This one here is important. I like this one. I'm expanding it to show you. Whenever the program stops, let's say you went over a limit, this would display unsafe. So it'll tell you why the program starts. The step index tells you what you're running. You're running current, or the voltage ramp, or internal resistance. We'll go down here and take a look at a few other things. This is your step time. So each step has a certain amount of time. And then there's a bit of an overlap of time too. So don't be surprised if you set your 30-second test up that it winds up coming out like 39 seconds or a little bit over. There's time for the system to come on and off. This is your actual voltage measurement. This is your current measurement. Charge capacity in amp hours. Discharge capacity, let's open that up, in milliamps per hour. Charge energy in milliwatts per hour, respectively. Discharge energy in milliwatts. Auxiliary voltage measurement, and then the rate of change of the voltage is displayed here. For example, in millivolts per second. Our temperature reading, and then the rate of change of the temperature reading as well in degrees per second. Our pressure reading, and respectively the rate of change of the pressure reading during the duration of the test. It's pretty complete, and again, if you're only working on one device and one channel, it's really very convenient to work off of the screen as well. So this is the entire system. Once you learn the software, it works very well. It's understandable, but it's always important to remember that you must set your safety limits. The piece of equipment has a range, but it doesn't know what you're hooking up to it. So whatever your storage or power source is, or your battery is, make sure you know its specifications so you can set the appropriate range in the software, and you shouldn't have any problems. And this completes this demonstration.